Hi, welcome to my first video. We're on our second lesson, 1.2 factoring polynomials. The two big ideas that we're going to be covering is the remainder theorem and the factor theorem. For get started, I don't think we need to go through and factor each of the polynomials. We spent some time factoring as a review earlier in this course, but I don't know, let's just take a look at this second one here. For looking at this trinomial, there's a common factor to the three terms. So we'll factor this one just as a practice exercise here. If we factor out an x, then we get our 2x squared minus 3x minus 14. Okay, now this is a little bit of work. Now we have to say, okay, we want to expand this middle term, and we're going to find two numbers whose product is minus 28 and whose sum is negative 3. So two numbers, one positive, one negative, that multiply out to 28. So maybe 7 and 4, and our larger one that would have to be negative if they're going to add up to a negative 3. So that seems to work out. Negative 7 and positive 4 multiply out to negative 28. Negative 7 plus 4 add up to negative 3. So we'll expand that middle term, 2x squared, and we'll put a minus 7x plus 4x minus 14. And then when we group these two terms together, I'm looking at the 2x squared minus 7x. Looks like there's a common x there. So we'll get x times 2x minus 7 plus 2 times 2x minus 7, keeping track of all my parentheses. So here I'm going to get x multiplied by x plus 2 times 2x minus 7. So this one we might say is the traditional way of factoring, and it can be a little bit of an effort to try to figure out, and using this expansion and grouping method to factor them. What we're going to be learning using our new tools of this remainder theorem and the factor theorem are some powerful tools for when we have even more complicated examples than this trinomial. If we have a whole pile of terms in a polynomial, the remainder theorem and the factor theorem will assist us. I'm just going to scroll down here. Looking at our construct understanding section, it says for each polynomial below, divide to determine whether the given binomial is a factor. Each binomial has the form x minus a. Evaluate each polynomial when x equals a. So there's really two things. The first thing is we want to do is the first one is whether it is a factor or not, and the second one is to evaluate each polynomial when x is equal to a. So let's do the first one. It says, and there's even a question at the end to sort of hint, how might you tell whether the binomial is a factor without dividing? So we'll get to that in just a second. Okay, it is going to be a factor. X minus 1 will be a factor of 3x squared minus 2x minus 1 if it divides evenly. So really, using the method that we've done so far, I'll call this one A. So for part A, our question is if we divide it out, x minus 1, if we divide this into 3x squared minus 2x minus 1, at the end of the day, when we get down here, is the remainder equal to 0? So if the answer is yes, then we know it's a factor. If no, then it's not a factor, and we'll just keep on looking. So let's solve this. We've just another example, another problem that we've done earlier. So I'll say x goes into 3x squared 2x times. So I'll write my 2x over here. So I get 3x times. So I get 3x squared minus 3x, which I subtract. And so minus 2x subtract minus 3x, I get 1x minus 1. And then I'll say minus, or plus 1 here, x minus 1, and my remainder is 0. So a little bit messy here, but the question was, determine whether the given binomial is a factor, and so for the first one we can say yes. And the answer, and the reason is because the remainder was equal to 0. Let's try the second one here, b. But just for the heck of it, for b, I'll do my work over here, but I'll do it using synthetic division, so just to be a little bit less work. So there's no missing terms, my x cubed, my x squared, my x, and my 2, so I don't have to put any zeros anywhere. So I'll put my 3 here, minus 8, minus 1, and then minus 2. And remember, when you're doing synthetic division, you think of like the x minus a. So I don't put a minus 3, but I put a positive 3 here. So it's the opposite of whatever is there. The format is, if I bring down this 3, put it here, and this is when it gets multiplied. When you bring it up, do you multiply? So 3 times 3 is equal to 9 here. Negative 8 plus 9 is 1. Now, from when I take this 1, I multiply by 3 when I come up here, so I put a 3. Minus 1 plus 3 is 2. And then here I go 2 times 3 is 6. And this is where the remainder is. It's this last number, so my remainder is 4. So is this is x minus 3 a factor? No. Because the remainder is not equal to 0. The remainder in this case was equal to 4. And if I wanted to find out this answer, if you recall, this would be my x squared plus 1x plus 2. Let's not do C, but we can go on to the second part. It says evaluate each polynomial when x is equal to a. I'll switch to green on this one. So looking at my first one, so if my polynomial, I'll write it out sort of more like a polynomial. Oh, not such a good color. I'll switch with this polynomial here. P of x is equal to 3x squared minus 2x minus 1. So if they're saying each polynomial has a form of x minus a, so in this one they mean x minus 1, evaluate each polynomial when x is equal to 0. It's a little bit confusing the way they're stating this, but what they mean is they want us to evaluate this polynomial when x is equal to, in this case, 1. So what we want to do is find out what's the value when that polynomial has a value of 1 for each x. So I go 3 times 1 squared minus 2 times 1 minus 1. What will my answer be? Well, 3 times 1 squared is 3, minus 2 minus 1 equals 0. Hey, that's kind of cool. You'll notice something, that if I plug in a 1, I get a 0, just like that 0 over there. Leads me to wonder, what happens if I do the second question? And now in the second question, here's the function, p of x is equal to, so I'm just going to copy this section down here. P of x is equal to 3x cubed minus 8x squared minus x minus 2. And I'm going to plug in this case, an a value of 3. So I'm going to evaluate this when x is equal to 3. So it's 3 times 3 cubed minus 8 times 3 squared minus 3 minus 2. Okay, 3 cubed is 27, and times another 3, I guess that's 81, minus 8 times 9, which would be 72, minus 3 minus 2. I think I find this easier if I put together all my negative integers first. This is a 2. So negative 72, negative 3, and negative 2 combined together is a negative 77. So let's say this is 81 minus 77, and lo and behold, this is equal to 4. So I think we're ready to say, hey, we found a pattern that works. I'm just going to switch to the next page. Here they're doing another example. I don't think this is one of our 3 examples. They're dividing x minus 2 into this polynomial, and then they're saying down here, hey, let's evaluate for when x equals 2. So remember, x minus a, and then evaluate for the a. So if this is a minus 2, you're going to plug in a 2. And if you plug in a 2 for x in that same polynomial, you get the remainder. So this is the first of our 2 big pieces today. It's the remainder theorem. And this is stating, in more mathematical terms, what we've just discovered. When a polynomial, p of x, is divided by a binomial in the form of x minus a, this part here means where a is any integer. This funny z symbol here is the set of integers. So any positive or negative whole numbers. That's the set of integers. So a is a member of any of the set of integers. The remainder is p of a. So that's exactly what we're doing. So p of 2, the result was 47, and that's the same as the remainder of when you divide that same polynomial of x minus 2. Here's an illustration of why it works. If you're plugging in an a, we were doing this the other day, x minus a now becomes a minus a becomes 0, and you get the remainder. I'm not sure if that's so convincing for people, but just doing the work and noticing that it comes out that way seems to be better. Okay, what I'll do for example number 1 is first together we'll just examine the x minus 1 and the x plus 3 work, and then I'll do 1a for you, and I would like you to do 1b on your own. So looking at our 2 examples, we have, here's the polynomial, so we declare that as p of x. We say let p of x equal that polynomial, and use the remainder theorem. And so if it's x minus 1, they're going to be substituting a 1. Adding the numbers together, you get 20, and so they say the remainder is 20. What's different, there would be a clicking sound. What's different with the second one is that this is the first time where it's in the form of x plus some number instead of x minus some number. So you can think that this is the same thing as x minus negative 3. So the point in this case is that a is going to be equal to a negative 3. So when you substitute your number here, you're going to be substituting a negative 3. When p of x is divided by x plus 3, the remainder is p of negative 3. So substitute a negative 3 for wherever you saw x in the original definition of the polynomial, and your answer will be the remainder. So p of negative 3, they substitute all the negative 3's, they do their work, and they find it 0. So the remainder is 0. Oh, so by the way, we know this also, that if the remainder is 0, we could also say therefore, these 3 dots mean therefore, therefore this x plus 3 is a factor. So that's a nice added benefit. Like I said in the beginning, sometimes factoring can be difficult, and this remainder theorem and the factor theorem coming up is a nice way of figuring it out. I'm going to switch back to blue. Let's do the check your understanding 1a. Determine the remainder when this polynomial is divided by each binomial. So in this one, I'm just going to remind myself that a is going to be equal to 3 for our first example. For your example that you're going to be doing on your own, a will be equal to, let's see if you can figure that one out. I'm going to use the same p of x. I'll define it here. Let p of x equal, now here it is, 2x to the 4th minus 5x to the 3rd minus 5x squared plus 5x plus 3. Ooh, that's a long one. And I'm going to substitute now a 3 in. So I'm going to say p of, not x this time, but p of 3 will be equal to 2 times 3 to the 4th minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. I'm putting little dots instead of parentheses because it's easier for me on this mimeopad. 3 to the 4th power is 81. 81 times 2 is 162. Minus 3 cubed is 27. 27 times 5 is, I think, 135. I hope I'm doing this right. Minus 5 times 9 is 45. Plus 15 plus 3. So, I don't know, let's put together our negative terms first. Minus 135 and minus 45 is minus 180. And then I'll look at all my positive ones here. I'll do a double underline just to keep track of things a little bit. 15 and 3 is 18. 18 plus 160 is 180. Oh, look at this. So this is equal to 180 minus 180 is equal to a 0. So that makes me happy, so I know that that is a factor. I'm going to stop this now, and I'm going to let you try 1B on your own. Thank you.